Consider the vector given by a equals 4i plus 2j plus 3k. Find a unit vector lying in the xy plane orthogonal to a. Find a unit vector lying in the yz plane which is also orthogonal to a. And will the sum of the two unit vectors found above still be orthogonal to a? So for the first part, we're going to draw a coordinate. So the x, y, z coordinate. So x, y, z, and it's asking us to find a vector in this plane. So let's also draw the unit vectors. K hat, I hat, and j hat. So what would A look like? Well, since A has all positive components, it would look something like this. That's A. And when you think about orthogonality, you have to think about perpendicularity. And basically, what you're thinking about is a cross product. And it just so happens that when you take the cross product of A with K hat, you get a vector in the xy plane. So simply do A cross K hat, which is two I minus 4j. And the question asks for a unit vector. So to get a unit vector, you simply divide this whole quantity with the magnitude of A cross K. So for simplicity, let's call the resulting vector P. So P equals 2i minus 4j. And now the magnitude of P is simply the square root of 2i squared plus negative 4j squared. And since I is 1 and j is 1, if you square them, regardless of their orientation, they will always equal 1. So the square root ultimately becomes 4 plus 16, which is square root of 20. So p hat, which is the unit vector, is equal to 2 over the square root of 20 I minus 4 over the square root of 20 j. For part B, it's the very same thing, except this time you're now doing A cross I hat, which is so I is 0. So H would be 3j minus 2k. And now to find the magnitude of H, you do the same thing. It's simply the square root of 3j minus 2k, 3j squared plus negative 2k squared, which is just 9 plus 4, which is the square root of 13. So h hat is 3 over root 13 j minus 2 over root 13k. Now, the final question is, will the sum of the two unit vectors found above still be orthogonal to A? So for part C, we have the unit vector P and we have the unit vector H. And I call this vector M the addition of vectors P and H. So intuitively, if we look at this vector is not necessarily orthogonal to A. And the best way to check that is to do A dot M and set it equal to 0. Because if it was orthogonal, then the dot product would be 0. But spoiler, the dot product is not 0, and so for part C, P plus H is not orthogonal or perpendicular.